This is a nice example to start with because it actually steps you through many of the processes that you will be required to take in the future without being directed to do this. So it's let's have a look at it. You can see that features to point out, we're on the equator. We're on a 50-degree west and a 15-degree east longitude. We've also got a latitude of 48 degrees north. And right there in the middle of the Earth is our O. Now that becomes really important because that establishes the angles for both latitude and longitude. So from here up creates our angle, and you could see that would be an angle of 48 degrees. And also around on our equator, it's going to help us to establish the size of the angle there. What we can't see, but it's really important to realise, is occurring somewhere between these 50 degrees west and 15 degrees east. Somewhere in between, obviously, is Greenwich, our zero. So from Greenwich we go 50 degrees west, and from Greenwich we've gone 15 degrees east. So it's important to realise that Greenwich was not shown on this diagram. So what sort of things, I feel like it's always important, just like with any question, that you get a good understanding of what's given in the question before you start to answer it. So spend your time analysing the diagram, just like you would spend your time tracing through the words of a question, understanding what information's given. If you haven't registered all the information that's given, you're going to struggle to answer the questions. Okay. I feel like we're at a point where we can read the questions and get started. It says, what great circle passes through points C and D? Now, this becomes all pretty easy because we've noted the features of the question, of the diagram. So the great circle that passes through C and D is the equator. What is the angular distance between C and D? Now, C to D is here on the equator. What we can't see happening in between C and D is 1, Greenwich. What we can see happening is we've gone, that should be here. I'll just stretch that a bit. That is 50 degrees. So we know from the centre of the Earth and to Greenwich and around to here is 50. And then we have obviously another line of longitude that actually passes through point C. And we know that the angle between Greenwich and that location is a little 15. So when we're asked for the angle between C and D, we want both those. We've come 15 degrees and we've gone another 50. So obviously we've come 15 and another 50, which gives us a total of 65 degrees between C and D. And don't forget the importance of Greenwich sitting in there. And how did we know that? Because here we were west and here we were east. So if we've gone from east to west, we've passed Greenwich. Calculate the shortest distance between C and D. To the nearest kilometre, use the radius of the Earth as 6,400. This will usually be given in a question. So we know that this distance is found by using the formula L is theta on 360 times 2 times pi times r. Our angle we've just worked out to be 65 on 360 times 2 times pi, and we were told that the radius is 6,400. I'm sure you all know that, wrong one, that pi is just a number on your calculator. So let's go to the calculator. Oh, it's not going to move for me. Take your fraction button, 65 in your denominator, 360. You can be doing this with me. Times it by 2, times it by pi, and times by 6,400. And I'll see if I can move it. Oh yeah, it's going to move for me now. There it is. And we're getting 7260. I could just see in the question it said to the nearest kilometre. And you know that that would mean we cut off the 5, which rounds the 0 up to a 1. So 7261 to the nearest. And of course, the advice from the markers is to put that unrounded value in your answer before you round off. It's just that every time I go to write it, it disappears off the screen. And so I'm not going to do that, but certainly you are required to do that. What great circle now passes through AD? Well, that one's called 50 degrees west. It's a meridian of longitude, and it was called 50 degrees west. It makes a great circle with its partnering great circle, which is going around the back, which is obviously not called 50 degrees west, but it does join up with another circle around there. Calculate the great circle distance between A and D. So A and D, you might remember when we were first analysing the diagram, that I was pointing out the importance of the O, the centre of the earth, because it's going to give us the angle up to A, in this case, from the equator, which is 48 degrees. So we want L, which is 48 degrees on 360 times 2 times pi times r. And you can see there it gives 5,361 kilometres, 0.65. So again, we're cutting off a digit bigger, 5 or bigger, so we round this up. 5362, and again you're required to write the unrounded value, and like I said, and you're doing it with a calculator beside you, so you can see the number. Please write it down, then round it. Unlike me, when I go to write it, it actually disappears. What is the distance between B and C? Well, B and C are going to be exactly the same distance as A to D. So A to D was 5,362 kilometres. And that's the end of that question, so I'll stop the video now.